Hello, my name is Brian Saltworth. Today we're going to be talking about sketching a graph using the properties of zeros. We're going to cover about 6 things here. We're talking about the end behavior of a polynomial at plus or minus infinity. We're going to define zeros, talk about the fundamental theorem of algebra, what that means to us, turning points, and then multiplicity of zeros. So then we're going to sketch a polynomial. All right, so number 1. Here we go. The end behavior of polynomial. Sometimes it's referred to as, you'll see it as end behavior of, say, f of x of a polynomial, of the polynomial, as x goes to plus or minus infinity. You may also hear this referred to as the lead coefficient test, or the lead term test. These all mean the same things. Now, most things in here, I'm not going to go deep into why they work. That would be a different video or something. So this video is more for, you've read through it and you're trying how to put it together into a cohesive unit. So we're assuming that our polynomial looks like this. So as mentioned before, sometimes referred to as the leading term test, or lead coefficient test. So it means we're really going to be focusing in on this term here. All right, we're going to split things up into how does degree n behave, and how does a to the n behave. So make a little table here. We have 2 choices. N is even. N is odd. And then a to the n, or your lead coefficient, is either positive, so greater than 0, or a to the n, called the LC this time, is negative. So there's 4 cases. In general, let's end behavior talks about, well, let's look at a graph real quick. End behavior talks about what happens as x goes to plus infinity, so far right and far left. So we're talking about what's happening out here. In the center right here, in the center, it doesn't really tell us that much. That's what the zeros are for, to tell us what's going on in the center, but we're just talking far left or far right. So as we go to the far right, so as x gets big to the right, we go either up, we can go down. As we go to the left, x is very negative, so towards negative infinity. Y can go up, be positive, or it could be negative. So if n is even, either both ends will go up or both ends will go down. So again, note, if the lead coefficient is positive, they both go up, so everything's going to be positive. If the lead coefficient is negative, it's going to take everything and flip it down. So one thing I might make note of here, even degree is same direction. If you have an even degree, you're going to go the same direction, both up or both down. If you have an odd degree, your curves are going to go opposite directions as it goes to plus infinity and minus infinity. I'll make note, right here, x is positive, so y is going to be positive. Over here on the left side of this frame is odd. When x is negative, y is also going to be negative. So with a positive coefficient, positive x values turn into positive y values. Negative x values turn into negative x values. If we're down here, where x is, or a at the end, the coefficient is negative, positive x values have opposite y values, so it can go down. And positive y values, negative x values will have positive y values associated with them. Let's do a couple quick examples right here. So, discuss in behavior. A. Whenever in behavior, all we care about is the lead term. So, only I care about is the very first term with the highest degree. So all this other stuff, we're going to ignore for now. When it comes to getting to zeros and stuff, we would actually use that. But for now, okay. So degree is n, which is 5, which is odd. Odd degree means you're going to go in opposite directions. So one up, one down. So that means you're either going to have this case or this case. And then you say, oh, what's my lead coefficient? A5 is -1. For odd cases, right, look at this, for odd case, if your coefficient is positive, positive x gives you a plus y. Negative x gives you a negative y. If your lead coefficient is negative, you take the opposite, right? Positive x gives you negative y. Negative x gives you positive x. So we have a negative here, so we want this case. You might say, if you want words, so if you want to be fancy, as x approaches plus infinity, y goes to minus infinity. And as x approaches minus infinity, y approaches positive infinity. That's the fancy way of saying it. Or it could just say up left, down right. So those kind of two ways of saying the same thing. So fancy, got all the x's and y's and infinities, or just that way. Part B. All right, so here's one that's already been factored. We need to find the lead term in order to discuss end behavior. So one option is to multiply this big old nasty thing out and find all the however many terms it's going to be. I'm not going to do that because that hurts my brain. Here's what I know: if you multiply it out, x minus 5, that'd be x minus 5 times x minus 5. You end up with the highest power of x squared. So all we need to do to find the highest term of each of these things is find the highest degree within the parentheses. So x is the highest degree, then squared. So I got x squared here. 2x has a highest degree, cubed. So it's going to be 2x cubed. Over here, x minus 4, 1x. Outside has one power, so it'll be x. And then we're going to add on this 3 at the very front. So we work it out, our lead term will be 3 times x squared times 8x cubed times x. 24 x to the 6th. So your degree, or n, is 6. That's even. Even means both up or both down. So you're looking at that. Lead coefficient, our case, a 6 equals 24, which is greater than 0, which means positive stays positive. So we want this. You might say something, if you want to be fancy, say, as x approaches, in this case, it doesn't matter what I approach, plus infinity minus infinity. So I want you to do it one time. Y approaches positive infinity. Or you could just say both up. All right. So that's the end behavior. Now we're going to do zeros of a polynomial, which would say something like your number x equals c is a zero of the polynomial f of x if f of c equals 0. Again, sort of defining right there. So literally what we're saying is, remember, f of x is a y value, right? A 0 is the x value that makes, right, makes y equal to 0. In the past, you may have heard this referred to as an x-intercept, solution, or root. Now, if you want to look at the picture here, just kind of get a feel for it. let's call this x is minus 2, x is minus 5, and x is 2. Now note, the zeros are the points where y equals to 0. And that would be wherever we cross the y-axis. So here, here, and here. Whenever you cross the y-axis, whenever you cross the x-axis, is called an x-intercept. Okay. So let's look at an example of using zeros and in behavior. So sketch. F of x equals x plus 2, x minus 5, and x plus 7. Now, in this section video here, I'm assuming we've gone through all the ideas of how to factor this thing or find zeros with a polynomial. So this one, we're assuming that is all our polynomials will probably all be factored out, so we're not going to do that long work. So in behavior, my lead term, right, look at this, each of these in here, x plus 2 to the 1, x minus 5 to the 1, x plus 7 to the 1. Since they all occur one time, if I multiply it together, each parenthesis only provides a single x. So it's going to be x times x times x, or x cubed. So what does that mean? N equals 3, which is odd. For in behavior, odd means opposite directions, one up and one down. So we're going to have left up, right down, or left down, right up. And A3 is plus 1, which is greater than 0, which means positive x is turned to positive y's, negative x is turned to negative x. So if we look here, right, here's a positive x, which got us a negative y. I don't want that. I want a positive x turns into a positive y, and negative x turns into negative y. So I want this situation here. So I know I go up right and down left. All right, zeros. Zeros occur when the function is equal to, when y, or f of x is equal to 0. So we're going to solve f of x equals to 0. So x plus 2, x minus 5, x plus 7 equals 0. Since these are linear factors, right, x plus 2, x plus 5, single x, the zeros will always just be the opposites of what's inside. So x minus 2 equals x equals 5, and x equals minus 7. So here are my zeros. Now we need to sketch. I think I probably can get it right here. Just go ahead and mark the scale here. Let's go ahead and drop on our zeros. I have minus 2, minus 7, and 5. What else do we know? We know that we're going to go down over here and up over here. So if I'm going down as I go to the left, It means as I go to the right, I'm going to be going up. So I'm going up, I'm going up, I'm going up, I'm going up until I hit -7, 0, -7. I'm going to go through it. Now that I've gone through it, I'm going to go up unless I have to turn around. In this case, I have to turn around because I have to come back to this 0 right here of -2. So somewhere in here, we'll turn around, head back down, go through that, and now I'll keep going down unless I have to turn around. And I have to turn around because I have a 0 at x equals 5 right here. So I'm going to turn around, and we'll hit this. And I know I'm going to keep going because the behavior says that x increases, y keeps going. So I'm out of zeros. It's going like this. We can make it a little more. We can make it slightly more accurate by putting in the y-intercept. Right. This is our y-intercept right here. If you want to do the y-intercept, right, y-intercept means x is 0. So f is 0 to give us, okay, we're way up here, using this right here, which is, again, right here for easy look. So this would be 0 plus 2, 0 minus 5, and 0 plus 7. So 2 minus 5 times 7. That's minus 10 times 7, or minus 70. So our y-intercept point is the point x is 0 minus 70. So this point right here, if I do scale, it'll be way down there, but it's the point 0 minus 70. Now, this is a sketch because 1 is not to scale. 2, I have this maximum point right here on the graph and this minimum point right here on the graph. I don't know how tall the maximum should be. So I don't know if it should be up here, the minimum should be down here, or I don't know where it's at. I also don't know how far left or right it's going to be between these 2 points here. I know it has to occur in there, but I don't know how tall it is. There's some great ways to find out where the maximum point occurs, the minimum point occurs, and what the height of both those 2 points are. Those methods, unfortunately, or fortunately, depending on your view, are a Calc 1 topic. So it's a sketch because we're just kind of guessing where that turning point is going to be and how high it is. But it gives you a decent feel for what the behavior is going to look like. All right.